We're going to do that here in a second. So, ready? I'm going to zoom this out just a little bit so we can kind of see the whole circle. All right, so the unit circle is essentially, I'm used to a square board, not like this wide frame one. The unit circle is a circle with a radius of 1, okay? Because every other radius that you pick for a circle, you can scale sine, cosine, and tangent up to match that new circle, okay? So when I start this, I spiral it and go all the way around the inside, and then I keep moving around the outside, and we do it that way. All right, so I'm actually going to zoom it back in because this is stupid. All right, so let's start quadrants 1 and 2, okay? First color. All right, don't care what one it is, but first color. We're going to fill in all of our degrees. So this is 0 degrees. This is 30 degrees, 45, 60, and 90. We good so far? $120, $135, $150, and $180. Yep, same color. I'll tell you when to switch. All right, so far we've done quadrants 1 and 2. Quadrants 3 and 4. So are you guys noticing like a pattern? 30 degrees, 15, 15, 30. All right, so 30 more makes this 210, 15 makes this 225, 240, 270. Where did I cut my finger this time? All right, ready for quadrant 4? All right, 300. Yours might look a little different from mine. I can find this exact image. 315, 330, and 360. Okay? If there's not, just write it underneath 0 degrees. Just write 360 degrees. It's fine. All right. Now we're going to switch colors. We're going to go radians next, because radians and degrees correspond. I'm going to go red. All right, so when you start in radians, this is literally 0. Oh, for the love. Stupid technology. All right, 0 pi. This bottom one is going to be 2 pi. Is that saying a full revolution? All right, going all the way around. All right, as we go through and do this, your bases for your radians are going to be the same every single time we do this. So it's pi over 6, pi over 4, pi over 3. Why am I doing a line there? It's got a line. Pi over 3 and pi over 2. All right, I use the little line that they give you as a fraction line because I'm a little lazy about it. It works. All right, this is 2 pi over 3. This is 3 pi over 4. This is 5 pi over 6. And this is just a plain old pi. Kind of helps when you write the over 6. So my expectation when you see like 3 pi over 4 is you know it's 135 degrees. That is the ultimate goal. No matter what class you take next year, whether it's trig, pre-calc, 1148, 1149, this needs to be as memorized as your multiplication facts from when you were a little kid. All right? This saves you so much time. If you just know it, seriously, saves, like, your poor little brain won't freak out every time you see stuff with trig. All right? We're going to go down here. So, have you noticed the pattern with it starts with for my denominator? 6. So this is 7 pi over 6. This is 5 pi over 4. And then this is 4 pi over 3. Three pi over 2. 5 pi over 3. 7 pi over 4. 11 pi over 6. And then we're back up to 2 pi. Not until you're in, like, Calc 4 will you ever have to worry about imaginary numbers at the same time. They are real numbers, just not on the real plane. Just wait until you get in the hyperbolic geometry. That'll really mess with your head. All right, ready to switch colors again? You're going to want multiple colors. So 4 or 5 colors. Oh, you found them. Okay. All right, so on the bottom of your page, here's what we're going to write. All right, sine is always your y value. Okay, cosine is always your x value, and tangent is your y over x. You can do it with whatever color you want, but it helps when we fill everything in. The other big thing that I want to point out is Sohcahtoa. So opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. It's theta. For Sohcahtoa. Oh, that's just how I draw it. Most of the time the Greek letters, they do it sideways, but I write sideways, so I just do my slash through. All right, ready? So up next, we're going to fill in all of our cosine values. Okay, so all of our x's. So make sure you have a new color that you haven't used yet on the circle. So we said radius was 1, right? So if my radius is 1, what should my x value be right here? Just 1, okay, because it's flat. Okay? Now, this part blows people's minds. This is root 2 over 2. This is root 3 over 2. And this is 1/2. I will teach you guys a trick with your hands to help you fill in that first quadrant. Bless you. Now, as I rotate, and now I'm at 90, if my radius is still 1, what is my new x value up here? 0, because I'm on my axes. So, Are my x values going to change much from quadrant 1 to quadrant 2? Yeah, they're just going to be negative. So it's negative 1/2. And make sure you're very careful about where you put your x's, because it kind of flip-flops on this. Negative root 2 over 2, and negative root 3 over 2. Ready to do the bottom ones? What do you think it is? So 1, 0, negative 1. Yep. Do we think the x values change much when we're down here? No. They follow the exact same values that you had above it, because now they're just below the y-axis. They're still negative on quadrant 3. So this one should be negative root 3 over 2, negative root 2 over 2, and negative 1/2. X down at the bottom at 270. Yep, 0. Now quadrant 4 should be what? Yeah, it should be positive again. So this is going to be a positive 1/2, positive root 2 over 2, positive root 3 over 2. Ready for a new color? Now, I'm going to just kind of prove this to you guys real quick. You don't have to write this down. When we're doing sine, cosine, and tangent, and we're looking at a radius of 1, okay, we're working off of all 30, 60, 90 triangles or 45, 45, 90 triangles, okay? So if this is 45 and 45, I know both of these sides over here have to be the same, okay? So, to find that, do you guys remember this little table? X root 2, your answers if you're 45 and you're 90. No? Okay. I was going to say, you did, because this is how I teach it. So basically, 45, 45, 90 triangles have a ratio that they use. So if my hypotenuse is 1, and if I can stop dropping my stupid pen, that would be awesome too. Okay. I need to take this and I need to divide by a square root of 2 to get it. Alright? When I go to divide 1 by root 2, some old dead dude has decided we don't like dividing by square roots. So I gotta rationalize it. So, what's 1 times the square root of 2? And then what's root 2 times root 2? 2. Does that look familiar? Didn't we just write stuff down talking about root 2 over 2? It is kind of wonky, but this is where all of it comes from, your special right triangles. Okay? And if this freaks you out, don't write it down. We'll go over it more later. The same thing happens with 30, 60, 90, but the luxury with working with this is every time you see something at a 45, you know sine and cosine are going to be the same values. Okay? So if this one over here is root 2, this one also has to be root 2. The only thing you're focused on is where is it in what quadrant. So does it need to be positive? Does it need to be negative? Stuff like that. So if this one's root 2 over 2 for my sine, what does this one need to be? Are my y's over here positive or negative? They're still positive because they're above my axes. Okay? 30s and the 60s. Their sines and cosines flip-flop. Okay, so if this one's root 3 over 2, my sine is 1/2. And this one has a cosine of 1/2. So this is going to be root 3 over 2. And I don't know why I just wrote that backwards. Okay. My sine up here should be 1, sine down here should be 0, and then these just follow. Now what happens when I go from above my y-axis to below my y-axis? They're negatives. So, I know this one's got a negative root 3 over 2. What should my sine be? Negative 1/2. Negative root 2 over 2, what should my sine be? Yep, negative root 2 over 2. Alright. The 180, 0. Because it's right on the axes. Alright, and then down here, what should I have? Yep, they mirror. So this one's also negative root 3 over 2. Negative root 2 over 2. Negative 1/2. And then this is a negative 1. Because it's below your x-axis. You're looking at the y values, remember? Positive. I got extras. And this is why I recorded. Make sure if you do mess up, you can go back. Alright, last piece that we're doing are your tangents. Alright, now most of the time when they do unit circles, they don't ever put your tangents on there, and I don't really understand it because tangents are important. So we're switching colors. Alright, your tangents are your slopes. Okay? So if I have a horizontal line, what is my slope? 0. I'm not going up, I'm not going down. So it means my tangent here is 0 and 0. What about straight up and down? What are those slopes? Undefined. Now, the 45s have a slope of 1 and negative 1. Okay? Because remember, tangent is y over x. And if y and x are the same numbers, the only thing you care about is signage. Okay? So it flip-flops underneath my x-axis. Because this still has a positive slope. Because it's negative divided by a negative. Okay? Yeah. Alright. Now, the 30s and the 60s get funky when you're looking at it. So the way I have always taught my kids to do it is you're thinking in terms of what's steeper. Okay? So, what would be steeper as a line? The 30 degree or the 60 degree? 60, because it goes up faster. So this one is going to be square root of 3. What on God's green earth is it? It's just junk. Obviously. Stay. This one's just going to be root 3. Is root 3 divided by 3. Okay, so it's a third of that slope. when I jump over here, this is a negative root 3, and this is a negative root 3 over 3. So if I wanted to do what's 1/2 divided by root 3 over 2, I would write, hang on, let me write it. Woo. Give me a page. Yes. When I divide by fractions, what do I have to do? Okay. Now what? Okay. Or I could be lazy and just write it as 1 over root 3. So it's really the reciprocal of that slope, except some old dead dude, again, decided we don't like radicals in the bottom, so you have to rationalize, and that's where we get the root 3 over 3 part. Does that make a little bit more sense? Okay. And back here, we just need to fill in our slopes down here. So, remember, this creates a solid line going all the way up. All right, so my slopes are still the same. Root 3 over 3 and root 3. And then over here, I got negatives. Negative root 3, negative root 3. So, clear as mud? Anybody panicking? Like I'm going to have this whole stupid thing memorized? So, here's the hand trick. Hold up your left hand and go like this. Sorry, video people, you don't get to see this. Alright, this right here is my x-axis. This right here is my y-axis. If I put this finger down, this corresponds with my 30-degree or pi over 6 side. So I'm going to put it down. Root 3, 1/2. So, that means a word I can't say because I'm recording. Okay. So, if you look, when I put this down, this becomes my comma in between my cosine and my sine. Root 3 over, and then root 1. What's the square root of what? Yeah. No matter what, it's always over 2, right? Put down your middle finger. Root 2 over 2, and then root 2 over 2. Put down your pointer finger. 1/2, comma, root 3 over 2. Kind of a snazzy trick. Some people like it this way, because once they figure out that first quadrant, they can fill out everything else. Because I know these x's match, just this one's negative. I know these y's match because they're both above the y-axis. That would be considered cheating. And I don't think you could fit this entire thing underneath. Alright, so, all of that confusing stuff. You don't have to write any of this down. All I want you to do is put your finger on it when you find it on your unit circle. Okay, we're playing the, where is this game? Yes. So, pi over 2. Put your finger on pi over 2. Find it? We're working on it? Yeah, you got it. You're in the right spot. Alright, it says find x and y. So what is my x and y? 0 and 1. Okay. Move your finger to 3 pi over 4. What's x and y? Negative root 2 over 2. And then root 2 over 2. Alright, now we're going to get a little tricky with it. We need to go to negative 5 pi over 6. So, where's positive 5 pi over 6? Yep, positive 5 over 6 is up here. Okay? See this? If I go negative, I have to start from 0 and rotate it around, and I'm at the same spot just under my y-axis. So I'm technically at 7 pi over 6. Does that make sense? All right, so what is sine and cosine at negative 5 pi over 6? All right. It is pretty radical. Now, could I find sine, cosine, and tangent based off of these values? Can I do it just looking at my unit circle? All right, let's try pi over 3. So for pi over 3, sine, cosine, tangent. Cosine is, tangent is. Easy enough. So the entire point with learning the unit circle is to eventually memorize this, and that's all we've got